Today the students are reviewing 3 models for adding 2-digit addition problems: base 10, expanded form, and number line. The students first demonstrate how to solve 2-digit addition problems using base 10 blocks. The students manipulate the base 10 blocks, create groups of 10 when needed, and exchange for 10 rods. Next, the students demonstrate how to solve problems by drawing base 10 blocks. To show regrouping, the students circle 10 ones and then draw a 10 rod to replace the singles. The students then demonstrate how to solve the problems using a number line. To add larger numbers, the students jumped 10 and then added their ones. Lastly, the students decomposed numbers in order to add the expanded form model.
Oh no, it's gonna be.
Yep, it's in. I know that one. Maybe
Oh,
it's
it's
not
this 10.
good. It's maybe good. That's easy.
Okay. Solve this tricky problem. What are you starting with?
I would start with my ones.
But what are you building first? What are you doing first?
Oh, that is tricky.
Before you're counting, what do you have to do first?
Count my ones.
Well, before you can even count, what do you need to do? You need to get your tens, exactly.
Now there are 12. So the question is,
And then I'll count my ones and see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, got a 10.
Okay, so what are you doing here?
I'm grouping up a 10 and I'm grouping up 10 ones and I'm getting a 10.
Okay, so can you count your 10 ones and give them to me?
1, 2,
Put them in my hand as you count them. No, one at a time.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, and where did you get these from?
I got them from my ones pile.
Okay, can you show me your one pile again? Where did you get your ones? What did you have first? Okay, show me your 7 ones. You gotta always make sure we check our work. Count them and make sure it's correct, because you're kind of grouping them kind of quickly, and I want you to make sure you're taking your time.
That was tricky.
Okay, so your 7 ones came from 37, and then what do you have here?
I had 6.
How many ones?
1, 2, 3, 4, 5, 6.
Okay, now, let's try again. Now what are you going to do? So you double checked, you have the correct amount of ones. Now what are you going to do?
And then I'm going to count them and see if I need it.
Okay, do that. How about we move them over to a separate pile, because look what happens when we get them too close together. What could happen? I might count the same one twice. So let's try the strategy of moving them to a new spot.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good. So if you give me these 10 ones, now what do you need to do?
I'm going to get a 10.
You've already counted them, so you can just put them in my hand. You should. Good. And where do you put that back in the ones? Do you put the 10 back with the ones? Zion, here's your 10. Take it back. Hold your 10. Do you put it with the ones? Where do you put it?
You put it
You put it where? You're right. Say it.
in the
You put it in the 10s because now it's a 10 rack. Good. Now what are you going to do?
And then I'm going to 10, 20, 30, 40, 50, 60. And then I got 63.
Good. Does somebody else want to share how they did it?
Well, I had 6 over here, and I knew these others were like here, so I have them all together, and I knew I had to trade it in 10.
Okay. Okay, so how did you do that?
We count this side first, then we count the other side, and then I stop right there where I just said 10, and then I grab 10.
Okay, check again and make sure you have 10, because mathematicians always double check their work. Okay, so you can put those back, and what are you going to exchange it for?
A 10.
Okay, and now what are you going to do?
Count all together.
Okay, go.
10, 20, 30, 40, 50, 60, 61, 62, 63.
Do you have enough to make a 10?
Nope.
No, so you don't have to regroup this time. So now what are you going to do? You might want to write that down that you have 8 ones.
I have 4 10s.
And how much is that?
40.
Okay. Put your plus sign. Now what are you doing?
I'm gonna add them together. That equals 48.
Good job. So you used the base 10 model and you drew your base 10. You drew 10s and 1s. And why did you count your 1s first?
Because I might have a 10.
Good. Good job.
I chose expanded.
Okay, so explain to me what you did.
I know that 40 plus 30. I know that 40 plus 30 is 70, and 1 plus 7 is 8. So my answer is 78.
Very good. So where did you get used to
I
add?
used a number.
Okay, and how did you use the number line to add these big numbers?
So what I did is I dropped 33 was my first number, and then I jumped 10
And why did you jump 10?
because I wanted less space, so it wouldn't take like that long.
Okay, so where did you get the 10 from?
I got
How did you know you needed to jump 110?
man.
Your answer is correct. How did you know that you needed to jump just 110? Look at your number.
Because 15 has only 110.
Very good. 15 has 110, so you jumped 110, and when you jumped 110, what number did you land on?
I landed on 43.
Okay, and then what did you do?
And then I drawed 5 more lines and I jumped 5 more spaces. And I got 48.
Good.
Students use a variety of models to represent addition and subtraction problems. Representational models can include base 10 models, number lines, expanded form, and even student-created algorithms. When subtracting, students are not borrowing in the traditional sense. Instead, they use what they know about place value and number sense to subtract numbers. For example, traditionally students were told that they could not subtract 60 from 120 because they did not have enough tens. By modeling their thinking in a different way, students can see that they actually have 12 tens. 6 tens can be taken from 12 tens without borrowing. Decomposing and using number sense allows students to solve more complicated problems through modeling.
Okay, we have been working on how to add and subtract large quantities using different strategies. We've used expanded form, we've used number lines, we've used base 10 models. You guys have been really awesome at decomposing numbers. So today what we're going to do, I'm going to give you a few problems on the table, and I want you to select your own model to solve the problem. What model can you use to help you solve the problem? Okay? Alright, that's what we're going to do. You get what you get and you don't. Thank you. Alright, guys. Here's our problem. Are you guys ready? Alright. Can you please find the difference? And you can use your own model.
We go to base 10?
Yes.
All the 430.
Okay, so there's 100, 200, 300, 400.
Then put the 310.
3 tens, 10, 20, 30.
Then put the seven dots.
1, 2, 3, 4, 5, 6, 7. All right, guys.
This subtracts 100.
So now what am I going to do?
Now you have to subtract
3. Put a 1.
Well, what am I? I'm taking away 169. Do I have to start with the hundreds?
No.
No, I can start
with
whatever I want. Well, you said cross out 100.
Yeah.
All right, so we have that taken care of.
Then you hammer the 100
Why?
because we don't have enough.
We don't have enough because that's a 30 and that's a 60.
Okay, so we need another set of tens, or another set of some more tens, right?
Yeah.
Okay, so now we're just gonna hammer it. We always draw our hammer to break it apart. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now we have 13 tens. Can I take 6 from 13?
Yes.
Okay. 1.
2, 3, 4, 5, 6, 7. Wait, 7.
6. Good. Okay, 6. Now what?
You break up a 10.
Why?
Because you don't have enough ones. 7 minus 9. It
All
would
right.
be
So I'm gonna. Ready?
1,
2, 3, 4, 5.
6, 7, 8, 9, 10.
Now can I take away my 9?
Yes.
Okay. 1,
2, 3, 4, 5, 6, 7, 8, 9.
Okay, what do we have left?
1, 2, 3, 6 plus 2, 8.
Okay, 8 ones. How many tens?
1, 2, 3, 4, 5. Wait. Oh, 6.
6 tens.
And 2
2 what?
hundreds.
200.
Aha, I knew I was right.
268. Okay? So,